Welcome to LouTube and this video lesson on solving linear system word problems. And this is a note file that you can find to follow along on solving linear systems with word problems. And please do. The best way I find to teach this is just to go through some examples of how to do this and then list the steps that I'm following after I've gone through a few examples. So please feel free to follow along and write in your answers as you go, or just watch carefully and then do the questions yourself if you like afterwards, okay? So the first type of question I'm going to look at is known as a sum and difference question. What that essentially means is you're going to be asked to find two numbers with a sum and a difference are going to be given. And so the first step involved, well, let's read the question here. It says, find the two numbers whose sum is 44 and difference is 8, okay? So we know that the two numbers sum, which means add up to 44, and difference means they subtract. And so when we talk about difference, if I give you two numbers, like say, for example, 15 and 10, what's the difference between 15 and 10? Well, the answer is 5, and that's because if we take the larger number, 15, and subtract the smaller number, we get 5, and so 15 minus 10 is 5, and that is what we refer to as the difference. Okay, so to solve these, the best way to go about doing it, or the way that we're expecting you to go about doing it, is to identify the two numbers and two things you're trying to find in a question. Always identify what you're trying to find. So in this case, we're finding two numbers, and we're going to name them. We're going to give them variable names, and we're really exciting mathematicians, so we usually use X and Y. So we say let X be, and I generally say this, that the larger number, okay? I want to identify them. One is the larger number, and one is the smaller number. And let Y be the smaller number. Now, you don't have to use X and Y, but, you know, mathematicians tend to be pretty boring, and they use X and Y quite often, okay? Now, once we've done that, we've identified what we're looking for as X and Y. Once we can solve for X and Y, we're essentially finished our equation, and we can, our word problem, and we can write our therefore statement of what the two numbers are. So X and Y being those two things. So we need to come up with a couple of equations. We know the sum of the two numbers is 44, and so that tells us if we add X and Y together, we get 44. Sum meaning adding, right? So we can write an equation, say X plus Y equals 44. And then that is one equation, okay? And then we can look at the difference, okay? And the difference, as I explained earlier, is always the larger number subtract the smaller number will give us the difference. So in this case, it's X minus Y equals 8. And we have now created two equations. And so we want to now solve this linear system for X and Y. We want to find where they intersect. And you could do that by graphing. It'd be quite a graph because, you know, your intercepts would be rather large numbers. Your y-intercepts would be 44 and 8 once we move these x's over and playing around with it. And we could graph them. It would be rather challenging, but you could do it. You can also do it by rearranging y for y and using substitution. But if you look closely, the equations are set up nicely to be solved by elimination. So I'm going to use elimination in this situation just because it is so neatly set up that way. So I have a positive y and a negative y. So if I add these two equations, I'm going to be able to eliminate my y. So in solving, the very first thing we do is we label our lines, okay? And like most mathematicians, we're very exciting, and we use A and B to label them. And then I would state what A and B are going to be added. So I say A plus B are going to be added, and I add the two equations. And this here, X plus X, will give me 2X. Then I have Y, positive y plus minus y, that would be 0. And then I have 44 plus 8, and that is going to be 52. And now I'm in a situation where I can solve for what x is because I've eliminated the y. And that's the whole point of using elimination, is to eliminate one of the terms, okay? And now I can say x here equals 26 because I simply just divide by 2 here and divide by 2 there. Those are solving equation skills that by now we're getting mastering and we're getting much better at. Then I'm half done because I have identified my x value. I know one of the two numbers is 26. And so now what I can do is I can go like this and I can say sub x equals 26 into, and I can choose whether it's A or B. In this case, I'm going to choose A. I avoid the negative sign and Y, and that generally makes my life a little bit easier, okay? And so I get 26 plus Y equals 44. And in this case, you're going to subtract 26 from both sides, and you end up with the number 18. Is that right? Yes, 18. So, and if you're not sure, by the way, it's always good when you're doing these little things just to pull your calculator up. I have the calculator right here on the computer and just show kids that this is a very viable option. Minus 26 should equal 18, and it does, okay? And those options exist for you. I can just minimize that calculator unless I feel I need it again later, which I likely will. Now I have identified my x value, my y value, and normally we would say therefore the POI is, but in this case we're not going to say therefore the POI is. We're going to say the answer to the word problem, okay? So we must make sure our concluding statement is the answer to the word problem. And I'm going to write this as therefore the two numbers are, and I'm going to list what those two numbers are, 26 and 18. And you'll notice that if I add these two numbers together, I get 44, and if I take the difference, I get 8. And that's what the question said in the beginning, okay? And so I essentially have completed that question by writing the therefore statement. All right, so now we're going to move on to the second type of question, which is called an out and back question. And out and back questions, there's something you really need to know, and that is speed equals distance over time. These are definitely more complicated and challenging questions, and sometimes I even, take a little extra time to do these. So just walk your way through them as you use some prior knowledge. You already know that speed equals distance over time because we talk about things like, how fast were you going down the highway? Well, we were doing 80 kilometers per hour, and that's 80 is your distance. Per hour is your time, okay? So 80 kilometers per hour, right? I'm just getting the kilometer marker in there. That is already an indication of speed equals distance over time. And so we're going to use that information as part of these kind of questions whenever there's something, go out somewhere and come back somewhere, okay? They generally use something like a river or wind or some deterrent that does not allow you to travel at the same speed but use the same effort. And then they want to find out the speed of the wind or the speed of the river or whatever the resistance is that is involved. So in this case, a kayaker paddles down a river. Big surprise, outdoor ed teacher. So a kayaker paddles downriver 24 kilometers in 4 hours and then paddles back upriver in 12 hours. So it'll be the same distance. So you're going to paddle down upriver, you're going to go one way, right? This will be downriver, and then another way you go back to the beginning again, okay? The river obviously is not very fast current in order to do that, otherwise you would never accomplish that. And then it says, what is the speed of the river and what is the speed of the kayak in still water, okay? So if we were paddling in still water, how fast would the kayaker be going? And we got to assume that the kayaker is putting in the same amount of effort all the time. Not really realistic, but that's how we kind of deal with these math problems, or at least on average, they're doing the same effort all the time, okay? And the river would also be flowing at the exact same pace all the time in order to achieve this, okay? So what we're going to do is solve this question. First thing we need to do is identify what our x and our y are going to be, or we could use other variables if we wish. We could use r for river and k for kayak if we want. In fact, maybe I'll do that. I'm always hesitant to do this because I always screw up and I want to go back to X and Y. But let's try it and see how it goes for me. And if I make a few mistakes, bear with me because I tend to be kind of an X and Y guy. So what I'm going to do is I'm going to say let R be the speed of the river. And notice that this is something that you're being asked to find. What is the speed of the river, right? And then I'm going to let K be the speed of the kayak. And it's important to include in still water, okay? Because the kayak will move at different speeds depending on whether you're going down river or you're going back up river. So be careful that you include this in still water. It's important, okay? Now, what we need to do is identify the actual speed going downriver and the actual speed going upriver. Okay, and that can be a little bit challenging to do, but it's not that difficult. So speed, this will be the speed of the kayak going downriver, okay, will be the distance over time. So in this case equals 24 over 4, which equals how many kilometers did they travel in 1 hour is really what you're saying. Well, distance, remember speed, we go back up here, is distance divided by time. So that's where I came up with this 24 divided by 4. This is sort of like a common sense thing, but a lot of kids really struggle with this aspect, right? But in this case, going downriver, the speed of the kayak was 6 kilometers per hour, okay? That's how fast the actual kayak went downriver, okay? Then, speed of the kayak upriver. So we would expect we would go a little slower when we go upriver. And in this case, they went 24 kilometers. They would travel the same distance back, but it took them 12 hours. So it would be 24 divided by 12. And that would be 2 kilometers per hour, which makes perfect sense. You know, as you're going downriver, you're flowing with the current, you're paddling your kayak, and you're adding some speed to that process. And then when you turn around and you start paddling upriver, it's going to be a lot harder, so you're going to go a lot slower. And in this case, the kayaker went only 2 kilometers per hour. Okay. Now, what we're going to do is we're going to use this information to calculate the speed of the kayak and the speed of the river and the speed of the kayak in still water. So when we're going downriver, what we have to think is that we're going to have a certain speed the kayak goes in still water, and then we're going to add the speed of the river. So if I was paddling my kayak in still water, I'm going to go at a certain speed. I don't know what it is, right? And then when I get on a current, the current's going to take me going the same speed plus the speed of the current. And that is going to be my speed going downriver. So what I end up doing is I get going downriver, I have a calculation, and you can call this DR if you want. Downriver is what I'm going to call this. I'm going to have the speed of the kayak, which is in still water, the speed of the kayak in still water, plus the speed of the river, and that is going to equal 6 kilometers per hour. And then I'm going to have UR, upriver. When I'm paddling upriver, I'm going to have the speed of the kayak, and I'm going to have a resistance, which is the speed of the river. So I'm going to have subtract the speed of the river equals the speed that I actually go, which is going to be 2 kilometers per hour. And now you'll see this lovely set of equations here that I can solve. So I have the speed of the kayak plus the speed of the river, speed of the kayak in still water, I should say, plus the speed of the river gives me my downriver speed. And then I have my speed of the kayak less the speed of the river gives me my upriver speed. And so now I'm going to add these two, because if I add them, I'm going to eliminate the river speed of the river, and I'm going to be able to find the speed of my kayak in still water, which is really cool. So I say dr plus ur, okay? And these namings can be different. I just like to use these because it helps me understand what's happening here. It helps my mind wrap around this. It's going to equal 2k. This, of course, will be 0 equals 8. And so k equals 4 in this case. All right? And so what I know now is that my speed of the kayak in still water is going to be 4 kilometers per hour. And then, of course, I can write sub k equals 4 into, and I can pick A or not A or B, but dr or ur, downriver or upriver. I'm going to pick downriver just because there's no negatives in it, right? And that makes my life a little easier. Oh, dr, not A. I was going to write A there. Let me just erase that so that is really clear. So dr being k plus 4. So I'm going to have rk plus r. So r, 4 plus r, equals 6. Get my words right. 4 plus r equals 6, which is really the dr with k substituted in for 4. And therefore r clearly equals 2. So the speed of the river is 2. And now I've calculated my r. I've calculated my k, both here, and I just have to write a concluding statement that makes sense. So I'm going to say, therefore, the speed of the kayak in still water is 6, and it's kilometers per hour because these were kilometers per hour before, okay? So the units here go transfer down here. Sorry, what? The speed of the kayak wasn't 6. What am I saying? The speed of the kayak was 4. Did I get that right? Sorry, I apologize. It was 4 kilometers per hour. K here is 4. And the speed of the river is, oh, I knew that was going to happen to me, is 2 kilometers per hour. I was trying to squeeze that in without moving the screen, and I shouldn't have. Okay, the speed of the kayak in still water is 4 kilometers per hour, and the speed of the river is 2. So if I add those two numbers together, I get 6. If I subtract, I get 2 kilometers per hour, and that does meet up with the speeds that I came up with before. Okay, a little bit more challenging question, but has a lot of similar flavors to the sum and difference question. Once again, elimination seems to be the most appropriate manner, and I really simple questions, adding, subtracting, is quite easy. Okay, and they're not that difficult once you wrap your head around speed and distance and time and all that stuff. Okay, now question 3 is a lot more challenging for a lot of kids, okay, but it's still really not that difficult. So I'm going to go through one example here, try to take my time, and then we'll see how it goes with your solution and if you can figure out some other ones in the same way. These ones are referred to as items sold, usually some sort of ticket sales or something is being sold, and there's a quantity of them being sold. It's not just 1 or 2. And so we have to do some multiplication and stuff to find out total costs and sales and stuff like that. Okay? So in this particular case, a school is selling tickets to their spring arts show. On the first day of sales, they sell 7 adult tickets and 16 student tickets for a total sales of $129. Okay. On the second day of sales, they sell 9 adult tickets and 12 student tickets for a total sales of $123. And then the question is how much do adult tickets and student tickets for the spring art show cost? And I know most people, when I read this question the first time, I'm just like, oh yeah, right. How the hell are you going to find this out? Like, this is just crazy. But when we break it down, it's not too bad. So the first thing we want to do is identify what is it you're being asked to find. And you're being asked to find the cost or the price of an adult ticket and a student ticket for the Spring Art Show. And so then what we want to do is identify those as being your tickets that, or your variables that you're going to find. In this particular case, you can use A and S or whatever. I'm going to use X and Y. I don't like using S for student ticket. I don't mind using A. It's a pretty decent variable, but I'm just going to go with adult tickets are A, or X, and student tickets are Y, okay? And it doesn't matter what variable you choose. So what I'm going to do is say let X be the price of an adult ticket, okay? And then I'm going to say let Y be the price of a student ticket, okay? And that gets me started. And the neat thing about this is, remember that once I find X and Y, I've answered the question that they have asked me. So it's really important to say to yourself, did I make my variables, set them such that I will answer the question that is being presented to me in the word problem? And in this case, I have, because if I know what X is, then I know what the adult price of a ticket is, and I know Y is, then I know the student price of it. Now, the real challenge here comes from identifying the two equations that need to be solved in this case, okay? So I have 7 adult tickets and 16 student tickets, so I think of day one, okay? This is day one sales. And what I'm going to do is I'm going to call this D1, okay? And I call it D1 because it stands for day one. So you notice that I'm using names now that reflect what the information in the question is, and this helps me kind of sort things out in my mind. And if I sell 7 adult tickets and each adult ticket is worth X, that means 7 times the price will give me how much it is. So for example, if an adult ticket is $3, 7 times 3 would be $21 collected. If the adult ticket is $5, it'd be 7 times 5 would be $35. So I say that's 7X. And then we also sold a bunch of student tickets, 16. 16 times the value of a student ticket is Y, so that's 16Y. And how much did we collect in total? Well, we collected $129, okay? Now, the next day, day 2, so I'm going to label this equation D2, okay, would be 9 adult tickets, 9X, okay, plus how many student tickets sold? 12. 12Y, and that equals a total value of $123. Is that right? 9 adult, 12 student, yep, $123. Now my goal is to solve these two equations, come up with a way to solve them. And this one is way trickier because there isn't like an easy way to look at it. Graphing them would be, yeah, rather challenging. Substitution would be kind of tricky because I can see right away that I don't have any numbers. I'd be dealing with fractions for sure if I'm going to do substitution. And I'd rather to avoid fractions. So I'm going to use elimination again, but this time I'm going to have to find a way to make these two equations have an equal value somewhere. And so what I'm going to do is I'm going to sort of use it like that old fraction cross multiplication thing. And I'm going to say, I'm going to take D1 and I'm going to multiply it by 9. And what I'm going to do is I'm going after elimination of X, and I'm going to multiply this equation by 9 and this equation by 7, okay? So 9 times 7, 63. So I'm going to multiply everybody in here by 9, okay? 9 times 7, oops, better write the right number down, 63X. Okay, it's going to sound a little crazy, and I'm going to have to use my calculator here. So I'm going to pull up my calculator and set it over here to the side. And then I'm going to clear this. And I'm going to say 16 times 16 times 9 equals 144, okay, plus 144y. I'm going to pull up my calculator again, and I got to do 129 times 9, okay? And that should be a big number, 1,000. What was it, 161? I got to go back and look just to double check that. Yep, I got it. Okay. And then I'm going to do D2, and I'm going to multiply it by 7. Okay. So once again, 7 times 9 will be 63x. And this is where it comes in handy to have that. And then I'm going to say 12 times 7, okay? And I don't know these off by heart always. I mean, I should know 12 times 7, I think is 84, but let's just double check. 12 times 7 times 12 equals, there was right, plus 84, okay? Y, and then I'm going to have 123, and then I'm going to have 123, what was it, times 7. So 123 times 7 equals 861, okay? And I can see here that now what I'm going to do is subtract, and I should really write, you know, subtract here, D1 times 7 minus D2, that would be 9 times 9, D2 times 7. And I'm going to subtract these two here. And so 63 minus 63 is 0. 144 minus 184 is 60y. Okay. And then I'm left with, ooh, what is this here? 1161, well, that's 0, 0, and that gives me 300, okay? And y will then be, now I'm going to just solve for y, so I got 0 over here, that's gone, so I divide by 60, and I divide by 60, so that'll cancel these two. This will leave me with y equals 5. And now I know the price of a student ticket. I know what y is because I said let y be the price of a student ticket, and y is 5. And so I'm kind of half done my question, but I don't know the price of an adult ticket. So I'm going to go sub y equals 5 into, and it doesn't matter. I can pick either equation here, D1 or D2. Yeah, you know, it just, I don't know. I'm going to pick D2 just for fun. I think it looks like it'll be a slightly easier question for me, but I don't know that for sure. So let's just try it. Okay, so into D2. And that means I'm taking this equation and I'm putting 5 in where the y is. So I get 9x plus 12 times 5 equals 123. Okay? And this works out to 9x. I'll do the math here. I won't skip any steps. Equals 123. And then I bring the 60. I want to get rid of it. So I'm going to subtract 60 on both sides. That's the ideology I like to teach kids the most. That's 9x equals, and if you do the math here, it's 63. And then I divide both sides by 9, and x is going to equal 7. So isn't that nice? They work out to nice even numbers here, $5 and $7. So the price of an adult ticket is $7. The price of a student ticket is $5. Does that make sense? Do we usually charge a little more for adults than students? I'd say that's normally the case. It would kind of be weird if I got my answer where the adults were paying less than the students, but that's not how it's working in this question. So all I have left to do is write my concluding statement. And so I would then write therefore, an adult ticket costs $7 and a student ticket And you'll notice that I write out the full things, right? I don't cheat. $5, okay? An adult ticket costs $5 and a student ticket costs, an adult ticket costs $7 and a student ticket costs $5. I don't write D1 equals, or I don't write X equals 5 and Y equals whatever. I actually write the actual answer to the question that makes sense up here. It's very important that you do that if you want full marks, okay? So what are the steps that we follow? So step 1 is always identify what the question is asking, okay? And I say asking for. What are they asking you to find, okay? So for example, in this question, they asked to find student tickets and adult ticket prices, okay? Up here in the previous question, they asked to find the speed of the river and the speed of the kayak in still water. And then we set variables, okay, equal to what the question is asking for. So I'm going to say use let statements to set variables. And we use different variables, X and Y. We use K and R, and we use different ones, okay? Use let statements to set variables for what the question is asking for, okay? It's very important that you do that, okay? Then we have to, the real challenge is determine 2 equations. And determine, I got to put the number 2 in there. It's important. 2 equations from the question using the variables from step 2, okay? And each time we did that, okay, so we always use the variables up here. We look and read through the question and we create 2 equations, okay? Determine 2 equations from the question using the variables from step 2. And this is by far the most difficult step in solving word problems, okay? And then step 4 is solving the linear system, because essentially what you've done is you've created these 2 equations, right? Solve the linear system and find the values, should I say, values for both variables. And then the last step, which is kind of important, is number 5, is to write a proper concluding statement that answers the question. That answers the question, okay? And you are done, okay? It's important to do that. And that is it, folks. That is solving linear systems. The best way to go through this word problems is to actually do a bunch. I mean, as you work through more, you become better skilled at them. As we run into more problems in life with respect to these things, you just get better and better at it. All right. I'm going to end this now, and we'll see you on YouTube next time.